Welcome to the lesson on 13.2, exponential decay function. The essential question here is how is the graph of g of x, a times b to the x minus h plus k, where in this case is b is between 0 to 1, how is that related to graph of f of x equal to b to the x? So this is very similar to what we had before in the previous section, except instead of having base 2 and 10, we're dealing with half and 1/10 of x. How does that change things? Well, in this case, the b is between, the base is between 0 to 1, where exponent is a variable. But one thing that I want to show you is that, point out to you is that if the base over here is converted to 2, then this becomes 2 to the negative x, right? It'll be 10 to the negative x. So that gives it if you negate the x value, what happens to it graphically? Can you imagine? If you don't have the answer yet, we'll see in a few minutes. All right, guys. Continuing on, if b is between 0 to 1, we call that function exponential decay function. If b is greater than 1, the function is called exponential growth function. So we have this table over here. Why don't you pause a little bit and try filling it in? Try to do as much as you can. Welcome back, guys. So if you plug in the values to the function 1/2 to the x power, then you would have gotten 8 for the first one, because if you put -3, if you negate that, the base half becomes 2, right? And the rest should appear that way. And with the table that was graph that was given to you, if you plug in the 0 and -1, remember in the past we used 0 and 1 to use that to guide our graphs. This time we're going to use 0 and -1. Can you guess why? It has everything to do with the fact that instead of being 2, it's 1/2. What that means is that if you write that as a 2, it would be 2 to the negative x, right? Okay. Then if you plugged in the rest of the coordinate values, this is what we get, right? So it looks like basically 2 to the x that's been reflected horizontally, right? Exactly. When you have b between 0 to 1, this 1/2 could be written as 2 to the negative x, and that's it's a horizontal reflection of 2 to the x. That's why it goes the other direction, right? And when you do that, the function seems to be going down this way. Hence, it's called decay, right? Anyways, what's the domain and range? As you could see, the domain is all real numbers, and the range looks like it's bigger than 0, right? And y-intercept is equal to 1. That's when x equal to 0. What is your y value? And function is obviously decreasing, as we mentioned. Now, what's the in behavior? Well, before we do that, if you look over here, the y value seems to be approaching 0, but never crossing it or even touching it. And that equation seems to be y equal to 0, and that's the asymptote, right? So what will be the in behavior? As x goes to infinity, y appears to, as x goes to the right, that is, right? Y value is approaching 0, but never touching it, right? And then when x goes to negative infinity, my y value seems to be going up. Okay. So we have another one for you. This one is f of x equal to 10 to the x, or 1/10 to the x, right? Why don't you go ahead and fill it out, pause the video and fill it out and see how close you are to the actual answer. Okay, we're back. I'll just show you what the answers are. Moving on to the next. So graphing the transformation of this, what are the roles of the a, h, and k, is the same as before. Hasn't changed. The only difference, as you could see over here, is that 2 to the x looks like it's rising, and 1/2 x looks exactly identical, except it's a mirror image. It's been reflected horizontally, right? Once again, that half could be written as 2 to the negative x. When you negate the x value, you're reflecting it horizontally. And that is the same with base 10 against the base 1/10, 1/10, right? For the same reasons. Okay. So we're using those as a reference, and I want to give you a set of tables that I didn't give it to you in the previous section. But I would discourage you from just purely memorizing it, right? So essentially what it comes down to is that the reference point for the b to the x, if the b is between 0 to 1, we use x as a 0 and -1. When b was bigger than 1, we use 0 and +1. When you plug it in, you get 0, 1, and 0b. In the case of when the base is bigger than 1, like such as f of x is equal to 2 to the x, if you plug in 1, you'll get 0b, and the b will be 2, right? So in our case, for the base being between 0 to 1, we always plug in 0 and -1, okay? The asymptote was equal to 0. Now, how do you use that in with the transformation? So that 0 has been moved to the h, right? Right, so we plug in h. That's exactly it, okay? So 0 plus h. And then the reason I put in 0 plus h is to indicate that the 0 has been shifted to the right by h. And then -1 has been shifted to the right by h. So that's the way you should remember things, right? And then when you plug those in, I'd rather not you memorize this. If you do, that's fine. But if you just plug the values in, you're going to get these anyways, right? If you memorize it, that's a plus. And then we're shifting vertically up by k. So what 0 becomes actually is 0 plus k. Sounds good? All right, let's move on. So how do I deal with this? We have to state the domain and range of the given function. Right, domain is all real number, and we notice that the x is less than 3. Why is that? If you say it's because the a is negative, you're right, because it's been vertically reflected. So instead of being greater than, it's actually less than. And my hk, you could tell, is 3 and 3. Very nice. And y is equal to k, so what that means is that my y is equal to 3. So that's my asymptote right there, guys, okay? So I answered the B, identify the new value as a reference point, HK, and asymptote. Okay, so using this HK, I could figure out my new reference point. So if you plug in for the H, like 0 plus H, you get 3 and f of 3, which gives you 3 and 1. And you're going to plug in -1 plus H, which gives you +2. Plug into the equation, you will end up with -1. So we use those 2 points to graph. And then we had those 2 points, but it's sometimes hard to graph what it is. So we should probably add in the asymptote with that as well. And when you do, okay, the graph is supposed to approach asymptote but not touch. So it probably should be like that, approaching it but not touching it, and going down this way, right? So if you're not sure about how to draw a curve, I would plug in a couple more points, right, to give it a better shape. But if you did, that's the shape that you should get. Okay? All right. What else can we do? No? Oh, last one, D. Instead of describing domain and range, obviously that was a typo, that it says describe the in behavior. Well, as x goes to infinity, y is approaching 3. And then as x goes to negative infinity, it's going down to the left, so it's negative infinity. Looks good? All right. Why don't you guys pause the video and give it a shot? Okay, guys, I'll be showing you off the answers. And if you got these on yours, you're doing a great job. Okay, moving on. Okay, so we have now a graph. And obviously, these two are the 2 reference points that we're dealing with. So how do I do? How do I do this? Well, we should identify the parameters, right? The first parameter is given to us. B is half, the base, that is. And h is -2 because that's the first point. We always give you that point, right? Okay. And then k, asymptote is given to you. And that looks like it's 3 coming here. 1, 2, 3. That's correct. And then we use the equation g of x equal to 8 times b to the x minus h plus k. So we plug in the known values. And when you do that, and we also note that that particular equation goes through -2, 6 and -3, 9. They're both easy numbers. Then if that's the case, I tend to go to small numbers. It goes through -2, 6, so you can plug it in. So my x is -2, my g of x is 6. And then from here, -2 and 2 here is 0, so it looks like a is 3. Yep, a is 3. So you gotta do a little bit of algebra, a little bit of arithmetics, and a equal to 3. Do you know a way to figure this out a little bit quicker? The a value, that is? Yes, the distance between the first point of reference and the asymptote, that's a value, by the way. So that is f of h minus k, 6 minus 3 is equal to 3. Okay, now that we know that a, b, h, and k, we could state the answer. So g of x equal to 3 times 1/2 raised to the power of x plus 2 plus 3. Alright guys, why don't you try b and see if you can replicate the effort. Go ahead. Okay guys, I'll just show you the answers that I got. We identify the parameters, and then there you go. Yay. Now, the way to see the h's really quickly is that I gave you the value of the y value here, right? 5.75. And my y asymptote, horizontal asymptote is 6. So the difference is 0.25. But because it's like pointing down this way, it must be negative, right? So a is negative 0.25. Okay. Or you could just plug into the equation and figure that out, just like over here. Okay. All right. So we got a word problem here. Eric Bear purchased a 2,000 Pawnee Firebird for $6,000. KBB website estimates that its value will decrease by 15% per year. Graph using the TI calculator to find the number of years it will take for the value of the car to be 5,000. Right, looks kind of similar to what we did before, but in this case, it's decreasing. So it is actually, oops, that should read decay, modeling with exponential decay functions. Sorry, could you change that please to decay? Very good. All right, first identify the parameters. My initial value a is equal to 6,000. That's what he bought it for. Common ratio. What's my base? Well, in an interest rate problem, it's always the base is 1 plus or minus r over 100. Because this is a decay, it's decreasing, hence minus, right? When you plug those values in, my base becomes 0.85, meaning the following year, the value of my car is 85% of the previous year because it's decreasing by 15%. If it was increasing, we'll add 15% to a 1, which will give you a 1.15. All right, as beautiful as the cars are, unless it's a collectible item, cars depreciate. All right, so we have the equation. The price n represents the number of years after year 2000 is equal to a times b to the n. So on your calculator, y1, the first equation should be 6,000 times 0.85 to the x. The second equation should be the price that you wanted to hit, 5,000. Be careful with the windows you set. I'm probably going to assume that it's not going to take 20 years to go down that much. So let's try 13, or you could try maybe 20. I like -3 or -5 to give a little space to the left. My minimum is -3,000. Seeing that Eric purchased this for 6,000, I like to have a little bit of room on the top. So I went 10,000, and I want my tick marks to be every 1,000, and for the X just 1,000, right? So the window is pretty important, guys. Okay, so you have to have a sense of the size of things, right? So the maximum value of the car is 6,000. So just give it a room on the top, make it 10,000. It's not going to go below $0, I hope not, but we'll give it a little space in the bottom, -3,000, and so on and so forth. Now, once you hit trace and hit the calc button, second calc, right? Right, so you're going to find the intersection of the two right here, right? I showed you how to do that in class. When you do that, answer comes out to 1.12. So you could conclude that, therefore, it will take 1.12 years for Pontiac fiber to depreciate to $5,000. Alright guys, have a good night.